This video covers the voltage difference in a uniform electric field. So this is what a uniform electric field looks like, and it means that everywhere the electric field is present, the strength is going to be the same, and the direction the electric field is going in is also the same. So we know that if we place a charge in an electric field, it will feel a force of this magnitude. And we also know that work is equal to force times displacement. We can then substitute in our force exerted on a charge in an electric field equation. And we also know that the voltage difference is equal to the work that it takes to move a charge in an electric field divided by that charge. So we can substitute in our work equation that we just developed. We see that the charges cancel, and we are left with the voltage difference equaling the electric field multiplied by the distance a charge moves. So this is what the formal equation looks like. You can see that we changed the variable for distance, and this is because the distance is not just simply the distance the object traveled, but rather the distance the object traveled and only the parallel to the electric field component of that distance. So if we move a charge from A to B, we really only care about this distance S here, because this is a distance that is parallel to the electric field. And this perpendicular distance right here, that voltage difference is going to equal 0, so we don't really care about that component. Let's do an example. An electric field of 200 Newton coulombs points in the positive y direction and has several points. Indicate which point has a higher voltage, and we want to, great, okay. So this is what our electric field looks like. And our points are A at 0, 0 and B at 6, 0. We see that the y-coordinate didn't change between these 2 points, so therefore our S value is going to be equal to 0, and the voltage difference between these 2 points is also going to be equal to 0. Next, we're going to look at the point C at negative 3, 5 and D at 8, 12. We know that we should only look at the y values since the electric field is pointing in the y direction. So the electric field is 200 Newton coulombs, and we know the distance between 5 and 12 is going to equal 7, and this is going to give us a voltage difference of 1,400 volts. We also have to answer the question at which point has the highest voltage. We know from our diagram that voltage levels decrease along the electric field, so the point at the lowest y value is going to have the highest voltage. So we know that point C, which has a y value of 5, which is less than 12, is going to have the higher voltage. And finally, we're going to look at the points S at negative 4, 10 and T at negative 7, 6. Once again, we only care about the distance in between the y-coordinates, which is 16, because to go from negative 10 to 6 is 16 points. So we see that our voltage difference is 3,200 volts. And once again, the point with the highest voltage is at the lowest y value, which in this case is negative 10 at point S.